All right, today we're going to take some time and go over some of the problems from our 3-3 textbook. So we're looking at these problems. Today we're going to definitely focus on number 19 and then the 2 word problems on 15 and 20. We might be able to squeeze something else in. So problem 19 has 3 inequalities. The first one is y is less than or equal to x. The next one is y is less than or equal to negative x plus 2. And y is greater than or equal to 0. So I like to double check, make sure I've transferred them correctly, and then we're going to go ahead and graph these 3 inequalities just like we would individually, but we're going to look for the final overlap. So this is all coming back to what we did in chapter 2, graphing inequalities. We've had a lot of practice with graphing equations, systems, and inequalities. This is one that catches people. So I need you to just take a minute and imagine that there's a 1 in front of the x, and then a plus 0. Now I see it. Now I see the y equals mx plus b. The slope is 1 over 1. The y-intercept is 0. So that, if that caught you, that's a really simple one. Notice that all of these are already solved for y. If it wasn't solved for y, we need to do that. If we multiply or divide by negative, we flip the inequality. So those are some reminders for you. I'm going to go ahead and plot my point at 0, rise 1, run 1. And I like to put extra points on my graph because I need to see where they intersect. So there's points. Grab a ruler, a straight edge, a note card, and sketch in a solid line because it is equal to. And then we need to shade. Now it's your decision. Some people are shading everything, but if it gets a little too messy, you might want to try to compartmentalize each piece. So there's 2 ways of shading. I'm going to use the idea that the y value is less than or equal to the line. So if you look at your y-axis as a number line, so no left and right, we're talking up and down. You got to break that left and right. The y value is up and down, and the y value's got to be less than where the line is. So here's the line. Here is my y-axis. As I go down the y-axis, that's where y is less than the line. So I'd be shading this bottom half. So I'm putting my little arrows here to point me in the right direction. If you choose to shade, maybe use some different colors, shade lightly so you can see it. The other thing you could do is a test point, but I've had some people really upset and concerned that they can't use 0, 0. And it was really frazzling them. You cannot use the point if it's on the line. If I put 0, 0 in here, it is true because it is equal to it. I need to test something above or below. So this is where I have to jump out of my box and test something like 1, 0. So if I want to test it, I'll pick another point like 1, 0, and I'll plug it in. 0 is less than or equal to 1 plus 0. Yes, 0 is less than or equal to 1. So this point works, so I would shade this half. All right, next one here has a negative slope. I have a slope of negative 1 over 1 and a y-intercept of 2. Remember, this is an ordered pair of 0, 2. It's on the y-axis, so slow yourself down, find that y-intercept. I'm going to go down 1 and right 1. So when you have a negative slope, your line should be dropping, and sometimes we're moving too quick. You get 1 negative, 1 positive. Go ahead and sketch in. Again, these are solid lines, but don't forget they might be dashed. Extend that line so you have the whole graph covered. And again, this one is less than. So if I look at where it cuts the y-axis gets smaller as I go down. So right now, my shaded region is here. My overlap is in this triangular chunk that goes down. Okay? So here I am. Again, I can use a test point. Because my line is not on 0, 0, I can test 0 is less than or equal to negative 0 plus 2. Yes, 0 is less than 2, so this is the half that shades. All right, I've got one more line here, and it's y is greater than or equal to 0. This is my horizontal line. Okay, we need to remember that. It's a horizontal line, and the slope is 0, and the y-intercept is 0. Y is greater than or equal to 0, x plus 0. So plot your point at 0, and then the slope is rise 0, run 0. So make sure you show this line. It's on the axis, but make sure you highlight it and go past it to show you've graphed it. And it says y is greater than or equal to 0, so we're going to shade up. So we have this whole section down here. My final shaded region is right in here, and that's it. So I'm going to go ahead and outline it. It makes a triangle, and that was one of the things that the textbook asked is, what shape does this make? I'm okay just saying that it makes a triangle. The textbook, if I could spell it, said that it is a right isosceles triangle. I think in order to claim that, you would have to do a little more to prove it. So we're just going to say that it's triangular in shape. All right, one thing I want to remind everyone of, if you have an inequality that is x, so if you have an inequality that says x is greater than or equal to, so let me just throw this up here real quick. If I have something that's x is greater than or equal to 2, in order to graph that, I want you to remember that that is going to be a vertical line. Oh, I'm really having trouble with spelling today. That is going to be a vertical line, and it's going to cut through the x-axis at 2. And because this one says x is greater than 2, we would shade over here. So the slope of every vertical line is undefined. So that definitely came up in some of the inequalities, so I wanted to remind you of that. Okay, so let's go ahead and talk about some of the word problems here. Number 15 was a word problem, and they're a little bit different than some of the word problems we've been focusing on, so I think it's really good to talk about it. So looking at 15, it says a musician is releasing a new CD. The record company will manufacture the basic CD plus a promotional CD. So we have two different types of CDs, and they're going to distribute it to radio stations. No more than 10,000 CDs will be made. So right off the bat, all the CDs together are going to be less than or equal to 10,000. And then it goes on, the number of promotional CDs will be at most 20% of the number of basic CDs. So there's your second one. I guess I could be showing this book. So if you need this, you could pause it real quick. Write and graph a system of inequalities that describes the possible number of each type. So right there, that's how I know what my variables are. Write and graph a system of inequalities that describes the possible number of each type of CD. All right. So let's define our variables. Because I'm graphing, I'm definitely going to use x and y. I'm going to start down here a little bit lower so I can show my graph. So x equals the number of basic CDs, or amounts of basic CDs, and y equals the number of promotional CDs. All right, next idea. They said no more than 10,000 CDs, right? So all of the CDs that are basic plus all of the promotional CDs should be less than or equal to 10,000. So there's my first concept. So that I should have no problem with. The total of each adds up less than or equal to 10,000 CDs. But the next idea is a little different, so I'm going to reread it. It says the number of promotional CDs will be. That's equivalent to saying the number of CDs, the promotional CDs, is equal to. So I know I'm talking about y, and I'm going to compare it. So it's not equal this time, but I know this fact about y. Y is based on there are most 20% of the basic CDs. Okay, so y is at most. So y would be less than or equal to 20%, so 0.20, of the basic CDs. So 20% of, meaning multiplied by x. Now, I would like to say, hey, that's my system, but we have two more inequalities to consider, and it's the fact that I cannot have negative CDs. Cannot have negative CDs. So if I can't have negative CDs, they have to be positive. And the idea is that the x, the number of basic CDs, has to be greater than or equal to 0. I can have no CDs, but I can't have negative. Y, number of promotional, also has to be greater than or equal to 0. So these are called implied constraints. Implied constraints. So I want to remind you of that. We've talked about it, but that is how we define it. This is what's going to keep us in the first quadrant. So implied meaning we should understand that there it's real life. Constraints are restrictions. All of these are considered constraints. We're restricting our values. So we're going to graph these. Now, since it's a word problem, the best way to graph it is normally to use X and Y intercepts because we know exactly where we're going to hit. We don't have to worry about slope. This I can do that with, but this has a positive slope. It's going to start and go up. So I don't have an X and Y intercept to start and stop me. So I'm going to have to work with this one. If I'm using my X and Y intercepts, I know the facts that my X intercept will always have a 0 in place of the Y value. And if I plug the 0 in, I get X is less than or equal to 10,000. And then my Y intercept has the 0 value for X, and I get Y is less than or equal to 10,000. So that's a pretty nice one to do. And so we're going to graph that. So that means I have to count to 10,000. So I pre-counted my graph, and it works out, if I count by 500s each block, it works out pretty well. So let me slide this up. So here's my first 500, here's 1,000. So I'm going to put in 1,000. There's 500, here's 2,000. So every other block, so make sure your first one counts as 500, then 1,000. Now if you've already done this and you counted by something else, that's okay. Just double check that you really have an even interval. Maybe you just say that this is 6, and then in the directions here, the title, you say that you're counting by thousands. So you could do that and save yourself some writing. So go ahead and get yours labeled if you haven't. And then let's put a title on this. This is the number of, slide that up, number of basic CDs. All right, same idea over here. When I counted it, I went off by 1 unit, and I'm actually okay with that. I didn't want to count by thousands. My graph would have been too small. So that's why I went ahead and went with this. If you counted by different interval, that's okay. Our graphs will look a little different, but they should be the same shape, have the same intersections. All right, so here's what I'm talking about. I'm off by just 1, so I'm okay with that because I can account for that. Okay, so there it is, and we were going to label this number of promotional CDs. So you get points for having an even interval shown. You get points for your labels. So even if you mess up your graph, those are some easy points to get. You get points for your system written, and obviously you're going to get points for your graph. All right, so here I go. I'm going to go ahead and do the first one. I'll do it in red here. That one is going to start off at 10,000, 0, and it's going to hit here at 10,000, 0. That's so much easier than worrying about slope. I can see where it starts and stops very easily. These are solid lines again. I'm going to go ahead and stop at these points because I know I'm going to get cut off. And both of these, X and Y, were both less than. So the Y value was less coming down, the X value was less. So that means I'm shading coming down. Okay, this caps us off. Now, the next one's a little bit iffy. How am I going to graph this accurately? And that can cause an issue. So I don't want to graph 0.20. The y-intercept is 0. So I would start down here, but how am I going to do an accurate 0.2? I don't want that. I want my slope as a fraction. So there's two options here. Change it to fraction, and if you think about that, isn't 0.2 the same as 2/10 or 20/100? And 2/10 is the same as 1/5. So I'm really going to rewrite that as y is less than or equal to 1/5 x plus 0. That's really helpful. Now I can see it. Okay? Now, because I have the same interval, this is really important. I counted by 500s on both of them. Because I have the same interval, I can use a rise over run of 1/5. So I can start at 0, there I am, and I'm going to go up 1 unit and over 1, 2, 3, 4, 5. Okay, when I went up 1 unit, I went up 500, and then I went over 2,500. And 500 over 2,500 reduces down to 1/5. So that's why that works. Up 1 over 1, 2, 3, 4, 5. up 1 over 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5. Like to have that accurate graph there. So that's one way of doing it. Again, I have to watch that I have the same intervals to use that for slope. So here is my solid line. It is going this way. And it says y is less than, so I'd be shading coming down or using a test point. So right now my shaded region's cutting right into here. Okay, how else could I have graphed this? I could have graphed it using a table. So if I didn't catch to change this to a fraction, or it was a really messy fraction, or my interval wasn't the same, like I counted by 500s and thousands, then I would have put numbers in, like I put 0 in, I get out 0. I put 1,000 in, I should get out, I think, what did I say? I have 20% of it. So I think if I put 1,000 in, I should get, 200. I want to make sure I had my decimal right. I was going to say 200. So I could do that, and then I would graph that point at 1,200. But you can see, again, I'm estimating, so I might need to find a better point. Okay, I have 2 more to graph, and that is the x is greater than or equal to 0. That is a vertical line with the slope being undefined. Cuts through the x-axis. So even though it's right on here, you're going to show that line. Make sure it's visible, that shows that you accounted for it. So there's that one. X is greater would shade this way, so it doesn't really change down here. And then the y is greater than or equal is my horizontal line, and that has a slope of 0. And it's, again, you want to make sure you show it. Using colors is great. It helps you differentiate what you're doing. And so basically that pops my final answer into this triangular region. So the x and the y cut it into that first quadrant. Now, that's it for this word problem. But we're going to be working on some things, and I'm going to ask you, give me a possible solution. So the possible solutions are anything in the final shaded region. So if you give me a possible solution that could happen for these CDs, maybe you pick something like 7,000, 1,000. Well, there's 2 things here. One, if you answered this, you would lose some credit. You need to say it's 7,000 what? It's 7,000 basic CDs and 1,000 promotional CDs. So you need to be specific with your labels. But there are lots of possible solutions. We are talking about whole numbers, no negatives, no decimals, okay? But if I'm picking something closer on the line, I better double check it, because my graph's not perfectly accurate because we're not counting by ones. All right, our next word problem we're going to talk about is number 20, and whether you know anything about football or not, it is a matter of reading the problem maybe twice to get some ideas here. So let me read it to you. In 2003, LaDainian Tomlinson led the National Football League in yards from scrimmage, which includes rushing and receiving. So he had the record. He had a total of 2,370 yards from scrimmage. So if we add up these, he gets 2,370 total, including 1,645 rushing yards. Okay, the runner-up is Jamal Lewis, but he had fewer overall yards from scrimmage and more rushing yards. So we're comparing Jamal using LaDainian's records. Write and graph a system of inequalities that models the possible rushing and receiving yardage for Jamal Lewis. So I have the inequalities right here. The rushing and receiving yards has to be less than or equal to 2,370. That makes sense because Jamal did not break or get the record. He's less than LaDainian. And then the other one said, so he has overall less yards, but he has beat LaDainian's rushing yards. So if LaDainian had 1,645 and Jamal had more rushing yards, Jamal's rushing yards Y is greater than 1,645. We don't have to worry about the x being greater than or equal to 0 or the y being greater than or equal to 0 because you could have negative yards. I don't think anyone and the National Football League is going to have negative yards and be breaking records. But we don't have to worry about those implied constraints here. So I, again, would graph this using my X and Y intercepts to help. And you want to watch how you count. I counted by 250 to make a good estimate. So let's go ahead and get that graph. All right, so I know this has been taking a long time to go over these problems, but I think it's really important to spend this time. So we just talked about number 20 out of the book. I'm going to go ahead and graph it. I'm going to use X and Y because I'm graphing, and I think it's good to stick with that. So the X value for this problem, they listed yards scrimmage is the overall, and they talked about rushing and receiving yards total. So what is the possible rushing, receiving? So I went ahead and let X be the amount or number of rushing yards. Double checking myself. And Y is the amount of receiving yards. All right, with that in mind, the total yards from rushing and receiving for Ladanian, who had the record, was 2370. Jamal had fewer overall yards of scrimmage, so Jamal would be less than but not equal to 2370. And then it went on to say that Ladanian had 1,645 rushing yards, and Jamal was a runner-up. So even though he had fewer yards of scrimmage overall, he had more yards for rushing. So, I'm sorry, let me reread that again. He had more yards for rushing. So for me, I used rushing as X, so X is greater than 1645. Now that's a little different than what I showed on the textbook because the textbook used the Y value. All right, so if I'm being honest, I had to pause this video, so I have no idea where I was. But this is number 20 out of the textbook. I think I was talking about how the textbook had defined the X and Y differently. So we might have different X's and Y's. We should have the same output, but our graphs might be flipped around. So mine looks like this. I need to label my axes. So again, I'm using the X and Y intercept of 2370 for both the X value and the Y value. And this is going to be a vertical line with a slope that's undefined. So that's going to be my vertical line. So I went ahead and I did a little prep work because there's nothing worse than having to erase all this. And I decided to count each block as 250. So I'm not going to show all that. So here's 250, 500, 750, and then here's 1,000. Okay? There's 250, 500, 750, and there's 2,000. And 250, 2,500, 2,750, and 3,000. I don't think I could have counted by hundreds. I could have maybe counted by 200. So I just went with 250, and this is going to be the amount or number of rushing yards. And I did the same scale over here in case I wanted to use my rise over run. Here's the 1,000, 250, 500, 750, so 1, 2, 3, there's my 2,000, and there is my 3,000. Oh, and I can stop there. And this is the amount of receiving yards, number of receiving yards. Okay, so I'm going to go ahead and get my graph going. So using my X and Y intercepts of 2370, Y 0 and 0, 2370, I am definitely estimating. So on the X axis, here's 2,000, 2,000, 250. So I'm going to be right in here. Same thing over here. Go right between these two, and let's connect it with a dashed line. So slow down. It's not equal to, so it's got to be under this amount. So make sure you have a clearly dashed line. Okay, add a couple more spots in there. There's my dashed line, and then Y is less than, and the X was also less than, so it'd be shading coming down here. Okay, so this is going to keep shading down, but again, I'm going to keep that in the first quadrant. The X is greater than 1645. I'm going to go ahead and this is a vertical line, so my slope is undefined. So here is 1500, so I'm going to go right above here. Again, this is a dashed line. I'm definitely estimating here, and I think with my ruler I've pushed it a little further than I want it to be. And x is greater than would shade here. So right now my final shaded region is in this pocket. And yes, it would keep going down, but I'm going to go ahead and cut it off at 0 because we know he doesn't have negative yards. So anything in here gives me a possible combination of rushing and receiving yards. So I could say that he could have 2,000 rushing yards and 250 receiving yards. I could also probably pull up here as 2,000 rushing yards and 500 receiving. But this is something that if I pick an answer in the shaded region due to me estimating, I would definitely want to put it in here and make sure that it's valid in both of those. Okay, so I know this is a longer video, but for 3 problems, but it's important to review these ideas. I'm going to take this one step further. For my classes, we have a packet, and it's Systems of Inequalities word problems, and this is what is going to be worked on. So what I didn't like about this is it doesn't come out and explicitly ask you to define the variables. So normally they say how many, how much, what's the cost. So I want to make sure we have these variables defined properly. A company makes backpacks and briefcases. They cannot exceed a daily total of 40 backpacks and briefcases. And here we have a maximum of 20 backpacks can be made in one day, and a maximum output of briefcases is 30. And then it says define the variables. So if you really read through this, I know how many total backpacks and briefcases, and I know the maximums, but I actually don't know how many. So X is going to be the amount or number of backpacks. And I'm choosing backpacks because they said that first. And this is going to be the amount of briefcases. And so at this point, you might, bring some of this information down. Now it says state the constraints in this problem. So when we go ahead and look at this, we're going to do the constraints. Write an inequality for each constraint, and I have a hint here that there's 3. So when I do this, see how it has a total of 40? All the backpacks is X, and all the briefcases, Y, is a total cannot exceed. So it's not equal to 40, it's less than or equal to 40. So if it can't exceed, it means it can't be more than. So it can be 40 backpacks and briefcases or less. All right, then it goes on, it has a maximum of 20 backpacks. So let's compare X and 20. If 20 is the maximum, then my backpacks have to be less than or equal to 20. And the maximum daily output of briefcases is 30. So let's compare Y and 30, and that Y value is less than or equal to 30. So that's a little different than some of the ones we've been doing. So that's why I want to bring that up. This very consistent with what we've done, but it's an inequality. Here is your vertical line. Let's give you a reminder. That's your vertical line with the slope that is undefined. You've got to lock that idea down if you haven't. And this is going to be your horizontal line. It's one of the biggest mistakes kids make, and it messes up the graphs and the answers. This one I would solve for Y is less than or equal to negative X plus 40. Okay, so next idea here, it says what implicit constraints exist. Okay, implicit constraints or implied constraints. In real life, what can we expect? What's a limit? So these are all considered constraints or restrictions. We want to know in real life what would be implied. There's 2 of them. Well, I have objects, and these objects can't be negative. So the implicit or implied constraints or restrictions is that I have to have a positive value for X and Y. Positive value for X and Y. So the implicit constraints is that X has to be greater than or equal to 0. So we talk about positive, it means 0 or greater. And Y would be greater than or equal to 0. So I actually have 5 inequalities. Okay, so that's where I'm going to stop with this one. But look, draw a graph and show the possible number of bags. So basically you're going to draw a graph with your shading, final shaded region, label your axes, use a scale of 5 for both axes. That helps you to use your slope. But you could also use your X and Y intercept, or you could use your slope, okay? Then you're going to state one possible solution, and so you need to make sure you label that answer also, and then show the solution works in all three inequalities. So whatever answer you pick, you're going to go back up and you're going to plug it in to show that yes, it works here, it works here, and it also works here. Now, it should be greater than or equal to 0. That's what keeps us in the first quadrant. So down here, I wrote the inequalities. So whatever answer you pick, you're going to plug in and show that you've made a true statement. All right, real quick, the next things I want to do is I just want to take you through the variables. So Alyssa plays soccer and baseball. She burns 400 calories an hour. Okay, every hour 400 calories playing soccer, and 50 calories an hour playing baseball. Each week she's going to spend at most 20 hours exercising and wants to burn at least 4,000 calories. So these are your total hours and these are your total calories. How many calories she burns depends on how many hours she practices. So X is not number of calories, X is the number of hours. So number of hours playing soccer. So that's something that gets people mixed up. Number of hours playing soccer and number of hours playing baseball. All right, so I'm not going to do all these constraints with you, but here are your constraints to list. And again, they have the different scales here to help you. And if you have one scale by 2 and the y-axis by 5, you cannot use the slope-intercept method, so you're going to want to use x and y. Again, pick a possible solution, label it, and then lay out your inequalities. There's one more problem here. It's talking about calculators. So if you read through it, it's very much like the other ideas. You have a total of calculators, 110 of these, 80 of these, and then each one requires 1 hour to produce for battery and 2 hours for the other, and you have 200 total hours. So you're going to have an inequality for each of these individually, so vertical and horizontal lines, and you're going to have an inequality that has to do with time, okay? But I want to make sure you understand that X, I'm going to let X be, they talk about solar power first, so X is the amount or number of solar power calculators, and Y is the amount or number of battery operated or battery powered calculators. Okay, so again, same idea. Please take the time to read through the directions to label your axes and work on this. Okay, I hope that helps. Keep working.